In the previous module, you learned about the characteristics of a blockchain. Let me remind you of two key aspects of the technology. First, a blockchain is not inherently immutable. You can in fact modify any block in a blockchain as long as you are prepared to recalculate the hashes and update all subsequent blocks. As it turns out, there are two distinct components to adding immutability to a blockchain. The first is making it hard to add or modify blocks. On a distributed public blockchain, this is accomplished by way of proof of work. It costs a lot of computer power to modify a block, an unimaginable amount of computer power to modify a lengthy chain. The second is by making it easy to detect tampering with a block. This is accomplished by making the blockchain public. If everyone who has an interest in the ledger has access to the blockchain, no one individual or organization can modify the chain without being caught. Now here's the difference between a database-based private blockchain and the distributed private or public blockchain. With a distributed blockchain, the presumption is that there is a mechanism for all participants in the chain to write to the blockchain. But you don't need write access to validate a chain, you only need read access. So when it comes to addressing immutability on our database-based blockchain, we can take two steps. We can make it very hard to modify a block, but instead of using proof of work, we can use security configuration and code. And we can publish the blockchain. We can make it available to all interested parties, every current employee, former employees, outside partners, auditors, government agencies, the general public, everyone. That way, if anyone in the enterprise tampers with the data, it will be instantly visible to the world. Oh, we'll keep tight control over writing new transactions. Only selected individuals and processes inside the organization will be able to do that. But anyone will be able to see the new ledger. There are lots of ways to expose data from Salesforce, and we'll review some of them in the next module. But wait, what about privacy? The whole idea was to keep data private, right? That's right, and that brings us to the second key aspect of the technology. Blockchain is based on hashes, and as you may recall, a hash is a one-way function. Given the data, it's easy to determine the hash. Given a hash, it's impossible to determine the original data, but is easy to validate if that hash matches a set of input data. In the previous module, you saw that a block hash was determined by hashing the transaction input data with the hash of the previous block. Let's change that a bit. Instead of hashing the transaction data directly, let's first create a hash of the transaction data and then have the block hash generated based on that transaction hash, along with the hash of the previous block. Now when you publish the blockchain to the world, only publish the blockchain records themselves, not the actual transaction data. Think about it. Your employees, partners, the public, they all have a blockchain that can be verified at any time. If you were to change any of those hash values, they'd know right away. But they have no idea and no way to determine the actual transaction data. Your corporate data is completely secure.